Hi everyone, welcome back to Learn Math with Jessie. Today we're going to cover how to solve absolute value inequalities. First of all, what is an absolute value? Well, it represents a number's distance from zero on a number line. This is always a non-negative value, meaning the absolute value of x is greater or equal than zero for all x. So let's take this example here. So if we want to take the absolute value of -3, this represents the distance from -3 on the number line to 0. And this distance is effectively 3 units, right? Same thing for +3. So if we have absolute value of 3, it's the distance from +3 to 0 on the number line, and this is also going to be equal to 3. Now that we understand what an absolute value is, let's look at a few examples. If we have absolute value greater than 4, what does this mean? It means what values have a distance from 0 on the number line that's bigger than 4. So it means that any value between -4 and 4 will be excluded, right? Because they don't have distance bigger than 4 on the number line. For example, if we take 3, the distance from 3 to 0 is effectively 3, and -4 to 0 is effectively 4. So then we have the union between these two regions. We have x smaller than -4, union x bigger than 4. Next, moving on to a different example. If we have absolute value of x smaller or equal 4, what this means is what values have a distance from 0 that's smaller or equal to 4. And that's going to be effectively all values between -4 and 4 included. And in the first example, it was 4 and -4 excluded. So I just showed on screen the example. If we have -2, right, the distance between -2 and 0 is absolute value -2, and it's 2. If we have absolute value of -5, that gives 5, meaning that has a distance bigger than 4 on the number line. So we have this -4 to 4 included region. Now, if we have absolute value and it's smaller than a negative number, there's no solution because absolute value is always positive or 0. And if we have absolute value that's bigger than a negative number, well, this is all real numbers, right? Because this will be true everywhere on the number line. Now let's look at our first example. So again, we always want to isolate the absolute value. So we're going to have to move everything that's not the absolute value to the other side. So we subtract 4 from both sides. We get 1/5 minus 4. And then afterwards, we put it on a common denominator. So you get 1/5 minus 20/5, which gives -19/5. So notice something here. We have an absolute value and it's bigger than a negative number. And when we saw that, it means that the solution is all real numbers because all real numbers will work for this given absolute value. Okay, moving on to the next one. We again divide by 2 on both sides because we want to isolate that absolute value. And now here's a little trick for you. So you basically need to copy paste the sign onto the other side and then do the negative of whatever you have on the side where you had the initial value. So in this case, we copy paste that sign and then we get -7 on the other side. Then we subtract the 5 and then afterwards we divide by 2 like we normally do for our inequalities. And then this is the range that we get. Now I'm just graphing it on screen right now to show you what this interval actually looks like. So it's -6 included until 1 included as well. All right, moving on to the next one. Again, we subtract the 2 first. Afterwards, we divide by 3. So then we isolate that 4 minus x. We copy paste the sign to the other side and get -1, 4 minus x, and then 1 on the right side. We subtract 4 from either side. And now this is a really important part. Notice that, right, we have a negative x. So we divide by -1. And remember from the previous video that dividing by a negative or multiplying flips the sign. So then we're going to flip the signs everywhere here. Again, I'm just sketching what this looks like on the number line. So we kind of separate this in 2 parts. We have x is bigger than 3 and x is smaller than 5. All right, now here we directly have the absolute value, so we can directly copy paste that sign to the other side. And now we add 1/2 to either side. So -1 plus 1/2 is -1/2, and 1 plus 1/2 is 3/2. Now we have all these fractions that we don't want to deal with, right? So let's multiply by 3 to get rid of the division by 3. And then let's subtract 3 from either side. So we get -3/2 minus 3 and 9/2 minus 3. Again, we put it on a common denominator, right? So that's going to be 2. So we're going to get negative 9 over 2. And then we're going to get 3 over 2. And then once again, we divide by 2. So remember, dividing is like multiplying. Dividing by 2 is like multiplying by 1 over 2, right? Now here we have another example where we have to subtract the 1 first. And then notice that we're dividing by a negative number. So that's again going to flip the sign. Right? Now, once again, we copy paste the sign to the other side and we use the negative value. And then we obtain this. And now we have to multiply by 3 to get rid of that fraction that we don't want. Now we add 1 back on either side. And then we divide by 2. And I've sketched out the solution because it's a little bit different than the previous ones we've been doing. So notice again, the negative 4 and the 5 here are excluded, and it's a union of these two regions here. Thank you so much for tuning into this video. I'll see you in the next one.